In this first exercise, we are going to compare two linear functions. We have two shops to buy ice cream. In shop A, we have to buy the cup for €1 and the ice cream is €5 per liter. Shop B, we have to buy the cup for 50 cents and the ice cream is €6 per liter. So first, we are going to write a linear function for each shop. In shop A, the linear function would be y equals 5x plus 1. And in shop B, the linear function would be y equals 6x plus 0.50. So now we are going to give variable x, the independent variable, the following values, and calculate the values we get for y for each of the functions. And this is what we get for shop A, and this is what we get for shop B. Now we graph both functions on a grid. And again, this is what we get for shop A. This is the line for shop A. And this is the line for shop B. As we can see, both lines meet. Let's have a closer look on 0.5 liters, which means that if we buy less than half a liter of ice cream, shop B is cheaper. But if we buy more than half a liter of ice cream, shop A is cheaper. For next problem, we are going to have to graph a quadratic function. Let's see. We have a paper plane thrown from a balcony and it follows the function you can see there, where t is the time in seconds and h is the height in meters. First thing we're going to do, graph the function. To do that, we find the vertex, vx and vy. To do that, we use the formulas we know. So Vx is 1.5 seconds. Vy is 13.5 meters. And now we find the axis intercept. The y-axis we can see in the function is 9. And the x-axis, we have to solve the quadratic equation, and we have minus 1.1 and 4.1. So the graph is as follows. And just by looking at this graph, we can easily answer the following questions. And here you have the answers. The last one is the only one that needs a little bit of maths, which is explained here for you. Here we can see in the graph how the plane is over 12 meters high between 0.6 and 2.4 seconds. Let's see now how we find the equation of a line when we are given the slope and a point through which the line goes. The slope is 1/2 and the point is a 2, 4. So the formula is as follows. We replace the slope by 1/2 and the coordinates of the point in the corresponding places. Here we can see using Desmos how that is exactly the line going through the given point and with the desired slope. Here we have a similar problem, so we do exactly the same. So replace m and the coordinates of A in the formula, in the point slope formula. And now we are going to see a different version of the same problem. In this case, they ask for a line parallel to the previous one and going through point B to 15. As the line is parallel, we use the same slope as in the previous one, that is 1/3. But we replace by the coordinates of the new point, to 15. And this is what we get, and we can see with Desmos that is exactly the line parallel to the previous one and going through the new point B, 215. And finally, the last version of this problem is when they ask for a line perpendicular to the previous one and going through point B, for instance, 215. If the line is perpendicular, the slope is the opposite inverse. So instead of 1/3, it would be -3, -3. So this is what we get. And again, Desmos is the appropriate tool to check that this is exactly the line we were looking for, perpendicular to the previous ones and going through point B. And in the last problem, we are going to find parameters in a function to make the graph go through the desired point. In this case, it's a parabola where we have an unknown parameter a, and we want the graph to go through point A, 215. So what we do is we replace the x and y in the formula of the parabola by the coordinates of the point, and we solve the equation for A.